as well. Good. So does anyone remember what we learned last week? What are the two algorithms? What did we learn? Joy, you remember it? How about you, Luke? Do you learn it? Do you remember that? One is jump search, one is interpolation search, right? So jump search is there's a formula. So what is the formula? You need to find the interval, right? The m value. M value, what is that m value? Do you remember, Joy? What? M value actually is the square root of n, right? That was the formula. And the interpolation search. So there's a formula for the position. So every time you need to calculate the position, right? Do you guys still remember that? Okay, let me go. Let me go to my slides. You say the jump search. Let me share my screen. You need to remember those algorithms because that will help you a lot. Okay, so this is what we learned last week. Can you see my screen? Ivan?
Yeah.
Okay, good. So my computer is busy on something. All right, so not sure yet what is my computer doing right now. All right, let me go down. All right, so it doesn't react to my mouse move. Let me stop sharing, see if I can change that. What is my computer doing? All right, so strange here. It doesn't respond to my mouse movement. Okay. If it does not move, react to my mouse move, then it's back to this one. This is a problem we're trying to solve last week. I asked you to uh, submit the code submission. So, uh, no, so I don't know why the PowerPoint file does not react. Okay. All right. So Eddie, yours, right? So let's review yours. Let me read. So can anyone see this? Can you see the code?
Very blurry.
Blurry?
You make it bigger.
Yeah, let me get it get a word here.
Thank you. Get it? Did I get everything? Right. So I cannot change the background icon here. Come on, let me. Okay. So this is your code. Let's quickly review it. Let me take a look at it. Let me review this. Let's review together. So import, open. So we get just text. Okay. All right. So this input. All right. So this is a integer value x g this. While true.
This isn't very efficient. I know this. I just wanted to get something out though for today.
Okay. So yeah, this really did not use what we learned. I think.
I wasn't here last class, so I don't remember.
Okay. So yeah, let me get to looks. Look, do you wanted to talk about your code? Okay, let me. Okay. Yeah. Talk about this. What is the this binary search? So what does it exactly do? So start end, right?
So first we have a function that's called the and just find out how many foods are needed to and in the analysis we use that function for the mid value is time to see if that's included this that's included and this is the middle so the mid and I'm gonna do that. And that maximum. Yeah. Yes.
Okay. So this NKM give milk. Let me see. This needed. So this needed you give it a 0 here. Okay. So in the very beginning, set it to 0. So give milk is what does it do? While G less than N, G is what is G here? Oh, G is milk have been given since so far. Okay. All right. So N minus G divided by X. So what does this do? This needed plus K plus 1.
So this is the and then it's and then if you have the kind amount and then divide by five, that's like the amount of So like not wide every single day. That is
So mean that does it mean that you can actually have more than K days?
oh, this is and then what finances, so it's better than this is our ones are moving. This is always being really
Hmm. I did not get the logic. Let me still think about this. Okay. So here you are trying to figure out how many days needed, right? How many days needed to give the milk is that the result, right? But this value, why is minimum, right? Hmm. So did you run this? You run it and you get the right result, right? So if you do this, did did you run into a situation that this number will larger than K? It should never, right? Should never larger than K. So so that's why I'm not getting I'm really not getting this logic here.
so it's not that's very awesome.
So the maximum days you need actually is n divided by m here, right? So you cannot get an x number larger than that. That's impossible. Is that true?
This is the Panama divided by one. I honestly is going to be always around. Um, so I really was very cool with these times. So it's such as my best.
So how can you determine this value is the largest then? The x value is the largest. Yeah. So here, and let me use the impact. N is the milk you owe. K is the days you need to pay back. M is the minimum, right? So the largest K, largest X cannot larger than, it cannot, right? It cannot larger than N divided by M. N divided by M It's how many days you need. Every day you pay minimum, right? And this value called larger than K. If it's larger than K, then it should not exist. So that's why you need to get into K, right? So why do I need to go to that file? Go to like what is the bounding you have here? Let me see. So bounding is in what is the max? What is the end? Or end is here. Okay. So start, end. Yeah. Okay. That is good. That will be good because x is the largest value you can take. Yeah. Then yes, you will get that one. So you need to keep doing that until you say you get the maximum value. Yeah. So yes, if you do that. I'm not sure, Evan, did you do any code for this one? Or like Stephanie, which part you do not get it? Did you do any code for this one? This problem actually is a silver problem. It's very hard. So if we think this one is hard, then we probably need to do more of the bronze examples. We need to do more bronze example. So to help us on that, because if it's too hard, then it's not easy to help to help us to improve much because it's too hard, right? Do you think this one is hard or not? This problem, it is hard. Okay. So Evan, did you do any coding for this one?
Uh,
No. Wait,
I
wait.
did some, and I didn't have time to finish it.
Okay. Yeah, I can feel maybe it's too hard for you guys. It's a silver problem. So look at what do you think? Is it very hard or it's okay? It is hard, right? Right. So let me go back to my slides then. So let me see if it's not does this work? Why? Miss why my if my slides doesn't work, then I cannot do the class. Let me see. Let me close this. It really takes me too much time to handle this. Hmm. Sorry about that. I don't know what's going on with my slides. Sorry. Let me check why.
Okay. Okay, so we come back here. So sorry about that. I think my stats has problem. So we need to remember the jump search. The intervals we need to take it. That formula, it's n's square root, and then we need to remember the interpolation. Okay, the interpolation search is the position for this formula. That is the formula. Okay, so what is the formula? This is the formula for the interpolation. So you need to find out the position here. So these are the formulas. So how to do the interpolation search? So you need to calculate the position. So once you have that, then you can do the interpolation. You can use that to do the interpolation. So today we are going to learn a very similar algorithm. And after we learn this one, I will stop talking about the searching algorithm. Okay. I hope we may need a little bit more time to keep you guys here because it wastes me a lot of time. So this is called an exponential search. So exponential search is an improvement of binary search. It's very, very similar to the interpolation search, okay? Or we say a jump search. Jump search, binary search, jump search. Jump search is from left to the right, right? The interpolation search, you calculate that position, and it's very similar to the binary search. Calculate that position, use that position to narrow down. It's not use the middle value. It's not use the middle value, okay? It's use that position value to split your list. So this exponential search is better than binary search, and why? It's an improvement. And it uses two exponent. Okay, the power use the power of two. The power of two to do the search. You are not doing the from like a middle. You are not calculating the position, and you just use two exponent. And why this is very helpful is why it is better than
and jump search. It is a kind of jump search, okay? It is kind of a jump search. It starts with 1. It starts with 1. And then it jumps 2, then jumps 4, and then jumps 8, then 16. So that's the jumps you take. It's not like in the jump search, you calculate the square root of the n value and keep that, use that to do the search. Okay. So you are doing it this way. Okay. You start from the left, but you increase the jump every time. Every time you increase the jump. And why this is better, okay? So of course you remember this. Once you find that value falls in the range, then you go ahead to the binary search in that range, okay? Once you find the upper bound value, it's larger than the value you're searching for, now you're doing the binary search for this subset area, So any question on this? Any question? What is the exponential search? It's a jump search. So the real jump search, you calculate that m value, that's the interval value. Interval value is the square root of the n, right? Here, you start with 1. Of course, the first one you do, you pull out the left one, the first one. And then now you start with 2. So you start from the second value, you jump 2 to do that. And then after you finish that, and then you jump 4. So that's how it does. So this is the function. So let me give you the function. Of course, I think you can get it from Google as well. So let me just give you this function. Let me explain this to you. Right? You see, you have an area, and then this is the n value. Okay, so this is the x value. X value is what you are searching for. Okay. So you see, if the first one is equal, it's easy. Return it. If then you know you increase I equal to 1, so you start from the next one, right? And then you see this is what you need to pay attention. This is the exponent. Okay. That is an x. Then we this is the moon. You can easily get x value. You can narrow down that sketch value. So you these two, okay. Every time when you do this part, it's very easy to do. It is very easy, very quick. Okay. So then you just times that one. You see, this will greatly decrease the iteration you needed to get into your search.
So I give you that code, and you see this binary search, and it will return that value for you, that index for you. Okay, it will return for that for you, and it will be very efficient. And I want you to keep this code. The next one is for Java. So let me skip that. So why do we need to do the exponential search? So you see, exponential search's complexity is log n. Log n is the complexity of a binary search, but it's more efficient than the binary search, so it's very good. It is at the same level, but it's better. It is better, okay? It's better. So it is particularly useful for unbounded searches. So what does it mean? That means your list keep increases. So you really do not know. You really do not know what is the maximum value of your area, but you know the area is ordered. So the value keeps changing. You can have more items coming into your area. You can have more stuff coming to your area, but your area is dynamic. It keeps increasing. So binary, this exponential search is much better than the binary search in that sense. So in the real world, you will run into that kind of situation, right? You will run into. So that's why this is very useful. So it works better than binary search for bounded areas. And also when the element to be searched is very close to the start on the left-hand side. So it's much more efficient than the binary search. So this looks is very abstract, right? Do you guys understand the algorithm? You understand the algorithm? Any question on this algorithm? Okay, I think you guys get lost here. So let me continue then. If you do not have a question, so let me continue. So linear search finds the element in n times. Okay, so linear search is n times. That's O(n). Jump search is the square root of n. N's square root. So that's why jump search is better than linear search. Binary search is log n. You see the exponential search is also log n, right? So you need to remember those, which search method is better. So both exponential search and the interpretation search are an improvement of the binary search. So it's at the same scale, okay? Same scale. On complexity, they are at the same scale, but it's better. It's better than binary search. The interpolation and the exponential search, okay? All right, so if you remember that, now we talk about this complexity. It's very hard. That's why I said, what we talked about this week, the past week, and the week past, if you have any breakthroughs on this, okay, it's a PhD level thing. And it may get you into like a big breakthrough will be very famous, okay, in the scientific area, because this is a real thing, business. It's not like I'm going to write some code and then I can push the robot to move forward. So
that code has been done by other people. Okay, we're just using it. Here, if you can increase the efficiency, and you can have a better algorithm, okay, you will be the famous person in the world. Okay, so this is the order, all right? This is the order. So O1, do you still remember what is O1?
The time the algorithm takes does not matter from the input.
3 times 5, O1. N divided by M, that's O1, right? Just one line of code, no like a loop. It really doesn't matter how big the number n is. You just do that statement, and then you get it done. That's O1. This is the simplest. Of course, you will never get that. You will never get that. Okay. So O log n. What is the log n? This one.
The time the algorithm takes grows logarithmically, meaning it grows at a very slow rate.
The log n, that's what we just talking about. Binary search, jump search, or binary search, interpolation search, and exponential search. So they are the most efficient algorithm. So always try to solve your problem using this kind of algorithm to do it. That will guarantee you that you can finish your code in within like 2 seconds. Within 2 seconds, with the numbers I give to you. Okay, what is the O n square root? That is a jump search, right? Jump search, you need to find the jump, the interval. That's the square root of n. That's the square root of n. So how many jumps you go? Okay. So jump search is not as good as binary search, but it is better than this. Okay. This is the linear search. That's the linear search. Okay. So you can see this is the worst case. It's the factorial. That is the worst case in algorithm. If you have that kind of thing in your code for bronze competition, it's okay. For silver, you pretty much you will not be able to pass. So I will give you an example. What does that mean? So you see here we have those. Okay. So let's take some examples to see what is the factorial algorithm. So avoid that, okay? So factorial is the multiplications of all positive integer numbers less than itself. So if you are n, that means you times 1, times 2, times 3, up to times n. So that's a factorial. It's very big. I give you a very big number, okay? So if it is one of the algorithms that you wanted to stay with, so when you program it for the computation, you try not to use it. You try not to use it. I will give you examples. What is the factorial, okay? One thing is the permutation. Permutation, what does it do? Solving the traveling salesman problem with a brute force search. Okay. Permutation of a string. What does it mean, permutation of a string? If I give you 3 characters, give me all the combinations of the position of the characters. That's a permutation. So it's very complicated. It's very time consuming. Okay. Salesman problem is a very classic problem. So that means, okay, if you are a salesperson, you need to go to 10 cities. You wanted to go to each every city using the shortest distance. You can get the shortest distance. So you see, when we use navigation, like a Google map, we do navigation. It needs to do all that kind of calculation. Okay, if you wanted to go to New York, you start from here. There are so many route segments that you can take. Which one give you the shortest distance? Which one give you shortest distance? That's a very, very complicated. Very, very complicated. Okay, it's very, very time consuming. But you nowadays, you say you have a cell phone, you can use that in your car, and it responded right away. So you say how powerful nowadays the computer is, the chips is, right? So it's a very big number, and that gets very complicated. You need to calculate that distance. So if you feel interested, you just search. Okay, come to search. Salesman algorithm. So this is a salesman algorithm. Okay, it's a classic problem, just like the Ed Queen's puzzle I give it to you. How can you put the 8 queens on an 8 by 8 plate? Okay, 8 columns, 8 rows. So how can you place that? It's a very classical problem. So here you see, if you want to you wanted to find the solution, use brute force. That is factorial complexity. Okay, so let me go to the next slide. To understand a permutation is a factorial, we can think it this way. Okay, let's assume an n character strings. Let's say you have 5 characters. The first character has n possible positions. If you have 5 positions, 5 characters, you get the first one, it has 5 possible positions. Okay, and then you get the next one. It has 4 positions, right? 4 possible positions. And then you get the next one. You have 3 possible positions. So that's why the total possibility is 5 times 4 times 3 times 2 times 1. So now I usually give the students this problem to do. If you have like 20 people in the room, every people need to shake hands with another person. Just shake once. Do not shake it twice. And then when you are the 21st one, you're the 21st people. So then tell me how many handshake has happened. That kind of problem is a factorial problem. It is a factorial problem, okay? It's very complicated. So let's move on.
So another intuitive way to think about permutation is to use recursive way. So when you read this, and if you are doing programming, okay, so when you write your code, you need to avoid using recursive function. You need to avoid it. It's better to use loop. Do not use recursive. Of course, sometimes you will have to write recursive, but I will suggest that you not use that. Because when you use recursive, you will call it and then call it a call it. That is exactly the permutation thing. The permutation. So that means the permutation of n characters relies on the permutation of the n-1 characters. So that's what we talk about. And a recursive function, a recursive function really does that same way. It shrinks when you get to the smallest value. You know what exactly the result is. But when you get into a bigger value, you do not know what the value is. So you rely on the smaller value to get the bigger value. So that's exactly the n string position. Okay, that's a permutation problem, and you do it using recursive way. Okay, for each individual order of this n minus characters, there are n possible positions for the nth characters to be placed on. So therefore, if the total permutation of n minus 1 characters is x, that means you already calculated the value for n minus 1. Then you get the n value that is n times x. N times x. Okay. This can be viewed using this diagram. I think it is too hard for you guys. But if you wanted to get to the silver gold, okay, this is very important. And we'll talk about our other algorithms. So you see here, you have one easy. Right? Now you got, you see, but no, this is not. So for this one, you have three positions. You have three positions. So that is why. That is why. You see, the growth. The growth. And so here is one, here is two, and then you get so the 1 times 2 times 3. So the only combination, or we see the permutation of the characters. The possibility is 1 times 2 3. So if you have 4 characters, it times 4. So can you just go ahead? You times 1 times 2 times 3 times 4, and up to 10. These are tell me what the value is. Can you guys go ahead and do that? 1 times 2 times 4 times 5, yeah, up to 10. What is that value? How big is it? 3 million? What? How much do you get? 3.6 million, right? Okay. So you say you only get 10. Okay. So in if it's 10, you only like 3 million loops. Okay. So in your code to, to do the computation, you are in the dead water. You are in the dead water because it is really too complicated. Too complicated. Okay. If you get into that. So does this make sense to you? Does this make sense? Give you 1 minute. If it's a linear, if it is a linear algorithm, you only need to look 1 million times. You get it done. But if your algorithm is a permutation, the biggest number you can go if you go to 10. If you go to 10, you already need a 3.6 million. So if for the salesman, if this salesman needs to communicate 10 things, and he needs to find the short distance, that means he needs to find the best 3.6 million possibility. It's, you see how big it goes. How big it goes. So that's why it takes a lot of time, okay, to calculate it. It's very complicated. It's the most complicated in big O notation. Big O notation is the factorial, okay? So I just wanted to make the point here for that. So you see here is the algorithm. So you see the in exclamation, that's the factorial. This complexity is so steep, okay? You see this one here, that's a log n, it's just like that, okay? It's a little bit more than 0.1. It's a lot less than linear search. So it's very efficient, okay? So if we wanted to be a smart person, you will see why when we write computer, if we just think, wow, this is so fun, we do that. But you see, actually, in the, behind the scene is that what is the best way to get the problem solved? So they, mathematically, they already tell you, okay, that kind of algorithm is the best. It is the best. So the factorial, that's the worst. Okay, I do not think you guys have time to do this, but I really wanted to talk about this one. So I want you guys to write the code. Should be very easy. Next when we come back, I will get in like 1 or 2 problems for us to work together to solve it. Okay. Today I will just ask you to do this one. This is an easy one. So as we understand this, for an unbounded area, okay, can we solve it? So what is the sort of equivalence of this one? Each value after the first is the sum of the previous 2 values. Okay, you see, middle one, that's the first value. Middle 1, 2, 3, 7, 8. Okay, the second is the Fibonacci number. Okay, it's a Fibonacci number.
So what I want you to do is that. What I want you to do is that the initial size of the dynamic list is 100. So you need to find out, okay, the largest value of the list if you have 100 items in it. Okay, so I have a search target. The search target. Its initial value is 300. Okay, it's 300. So every time you perform an exponential search to this dynamic list, the list size increase by 2. Okay. One, two, three, four. Okay. The list. Okay, first stage do 0. Second stage do this, right? That's 1. Okay. Or first is 1. Second is 2. And then 2 is get those 2. And then you do like a next stage is 4. So that means from this one to 8. That's 4. And then the next one will be 16. So you need it from 8 to go down to that number. Did you get my problem here? So I ask you, every time you perform a search, this dynamic list will increase by 2. The target value increase by 100. So the first time you search, you are searching for 300. Of course, 0 is not 300. You do not get it. So now you come to do this search now, search this 2. Now your target becomes 400. And then you search this 4, your target becomes 500. Because every time you increase by 100. So I want you to write the code to find out, okay, how many jumps you can knock the range for the target. How many jumps? I mean, how many search? How many jumps you can, and then you the right one pick is larger than of the target, not than the value of the target. Question? Look. Do you want to write it? So 0, 1, 1, 2, 3, 5, 8, 10, and then 21. It would, but first, okay.
Doctor, can you stay close to the computer? We can barely hear you, yeah.
On the whiteboard where I want the students to come here. So I'm just trying to write on the whiteboard to tell the students what exactly happens. So let me do it here. So wanted to show the students what does it mean. Okay. So this is a Fibonacci number 0, 1, 1, 2, 3, 5, 8, 13, 21. And then let me see, the first time I needed to search 300. Okay. 300, that's when you search 0, you search 300, you do not get it. The second time you are searching these two. Now your target becomes 400. And but for this number becomes now it's like a 34, 55, because you added two numbers to it. So you keep doing that. So tell me at which step, which jump. Then you say, let me just pretend that you have 600 and now you do, and then now what you get, this, let's say this is what else you selected. So this becomes 700. All right, this is the jump. This is the jump you get, and the red band you get is 700, and that means you already catch that in that jump. So you just need to tell me how many jumps you capture that number in that range. Does this make sense? Does it make sense? No? Everything? So you guys go back, use the jump search to do this, and give me the answer. And write the code to do that. Okay. All right, that's what I have. I will put this in the homework in the classroom. Any question, Eddie? Do you get my question? Do you get the problem?
Yeah, I got it. I got it. I'll do it.
Okay, that's good. All right, if you don't have questions, that's what I have for today. All right, I'll stop there.
All right. Thanks for talking to Andy.
Sure.
Bye. See you tomorrow.
See you.
Yeah.
你